Good morning, everybody. So, today we're going to be working with another topic that goes hand in hand with the distributed property, goes hand in hand with simplifying expressions as well. So, what we're working on today is something called factoring. This is basically the opposite of the distributed property. So, we're going to start off a little simple here. Let's think about this vocabulary real quick. You're going to see this word a lot. I've already said it. Factor. Okay, so what is a factor? Well, let's take 6. The factors of 6 would be 1 times 6 is 6, so we know 1 and 6 would be factors. We know 2 times 3 is 6. So 2 and 3 would also be factors. So 1, 2, 3, 6. Okay, so this is our set of factors here. So these are our factors of 6. Okay, so factors are numbers that you multiply together to get another number. So the factors of, let's say the factors of 8, that would be, we know 1 times 8 would work, we know 2 times 4 would work, and that's it. So our factors would be 1, 2, 4, and 8. So down here, these would be the factors of 8. Now, there's something we're going to need to know. I won't get into it yet, actually. But something else we need to know is factors are also numbers that we can divide by. Right? If we can multiply these together to get 6, well, we can divide 6 by these factors to get the others. So, for example, I could do 6 divided by 1. And we know that would give us 6. Or I could do 6 divided by 2. That would give us 3. Or 6 divided by 3 would give us 2. 6 divided by 6 would give us 1. Right? It's kind of like a loop almost. Circle. In fact, it is, and that would be there's actually college courses about that, but not going to get into it. So we have what we found here. These are our factors, are numbers we can multiply by. So our factors of 6 are numbers that we multiply together to get 6, but that also means they're numbers that we can divide by to get the other factors. So that's what we're going to do here, because I think that's the simplest way. We're going to take the coefficient. So remember, the coefficients are these numbers. We're going to take the coefficient in each term. Each one of these is a term. So we have 64 divided by 9. Does that give you, what does that give you? I'll tell you what, 64, it doesn't divide by 9. It doesn't divide by 9 evenly. Right? We know 8 times 8 is 64. But it doesn't divide by 9. You could try it out on a calculator if you wanted. In fact, Let's do this real quick. 64 divided by 9. 7.22222. Repeating. Yep, so 7.22 repeating. So this doesn't work. Um, you don't have to try out the other one at this point, but 56 does divide by 9. We know that 8 times 9 would give us. I'm sorry, 8 times 7. So no, if 56 does divide by 9 either, this wouldn't work. Little bit of a brain fart there. So neither of these work. So 9 is not a factor of 64c plus 56. Okay. So let's move on. Oops. Okay, so let's go on to where to go. There we go. All right, so 64 is not a factor. Now, is 6 a factor of 42w minus 12? Well, we have to think about, does 42 divide by 6? Does negative 12 divide by 6? Honestly, don't even really worry about the negative. Um, not right now, at least. There might be an example where we need it, but we'll see. So you just want to check, does 42 divide by 6? Oops. Maybe 7. Does 12 divide by 6? Oh, hopefully you know this. These both work. So, yes. Is 2 a factor of 16u minus 10? Try it out real quick. Okay, you should have gotten yes, it is a factor, because 16 divides by 2, and 10 divides by 2. Alright, let's skip ahead. Okay, so now this is when these get a little bit harder. Remember, I said we're doing the distributive property in reverse when we're doing these. So we're going to do that. We're going to do the same technique where we need to find um, factors of each of these numbers, but now we need to find something called the greatest common factor of these two coefficients. So we're looking for the greatest common factor. And I want you to actually really read that because it tells you exactly what it is. So it's the greatest, it's the biggest common. Okay, so we'll see what that means in a second. And then factor. And you're going to hear me and, you're just going to see this referred to as GCF very often. The greatest common factor, GCF. By the way, this is something that I've commonly seen on SATs. I know you haven't really taken it yet, but you're getting into high school next year. You are going to get that age where you need to start thinking about it. Greatest common factor is something I can almost promise there'll be one question on it on the SAT. Not much, but over time, every question makes a difference. So, anyways, let's get back to this. We're looking for the greatest factor in common between 21 and 15. So let's just list off factors of 21, factors of 15. I know 1 times 21 would work. 3 times 7, and I think that's it. 1 times 15, 3 times 5. Okay, so let's list off our set of factors. We have 1, 3, 7, 21, and then for 15, we have 1, 3, 5, 15. Okay, so when you're looking for the GCF, the greatest common factor, you're looking for the biggest factor, biggest number in common here between these two sets. So you might first see, oh, there's a 1 in both sets. Well, that's a common factor, but it wouldn't be the greatest common factor. We want the greatest common factor. So we don't want that 1. We see that there's a 3 in both sets. So our greatest common factor is 3. So our GCF is 3. Now we're going to use this GCF to factor this expression here. So we have 21s minus 15. Well, I'm going to do 21 divided by 3. And we said that works, right? 21 divided by 3 is 7. 21, oops, not 21, negative 15 divided by 3 is negative 5. So when we factor this, well, we're going to take our GCF, 3. We're going to put this outside the parentheses. And then we're going to do, let's see, we did 21 divided by 3. That gave us 7. So we're going to put this 7 here. We keep the S. And then we said negative 15 divided by 3 was negative 5. So we're going to do minus 5. So we have 3 times the difference of 7s and 5. So let's try this out. 3. Now I'm going to write this in, but real quick, I'm going to show you how you can check your work too. Because I did say this is the distributive property in reverse. So if we did this right, we should be able to distribute this 3 through and get what we started with. So we can do 3 times 7s, 3 times 7s, and then we'll have 3 times negative 5, so plus 3 times negative 5. This will give us 3 times 7, 21. S. 3 times negative 5 would be negative 15 plus negative 15 is the same thing as subtracting 15. Let me do. So that'd be your final answer, or not your final answer, but that would be what we started with. So that means that we did this right here. So we checked our answer. Everything looks good. Let's go ahead and press submit. Terrific. Okay, let's do another. So we have 36t minus 6. So we have 36 and negative 6. So we need the GCF. Now, the GCF is the biggest number that we can divide 36 and -6 by. It's the biggest factor these both have in common. So the biggest number you can divide 36 and 6 both by. So find the factors of 36. Okay. Now this can get a little harder with bigger numbers. With bigger numbers, you would want to use something called prime factorization, but it's not really something I want to spend all my time on today. So we'll see how it goes. We'll see what kind of numbers we see here. So we know 1 times 36 would work. We know 2 times 18. You see, as these numbers get bigger, it tends to be more and more factors. So it can be easier to miss one. Um, so there is a better way for it. It's just, I don't know if it's worth getting into. Might have to, your high school teacher might have to do that. So we have 36t minus 6. Well, we factored, or we looked at our factors of 36. We see that we have 1, oh, I missed 1, 3 times 12. See, very easy to miss 1 very quickly. So 1, 2, 3, 4, 6, 9, 12, 18, 36. Now we have 6 down here. We already did this one. Oops. We said that was 1, 2 times 3, 1 times 6. Okay, so now you're looking for the biggest one in common, biggest factor in common, GCF, greatest common factor. Excuse me. So we're looking for the greatest common factor. Well, we know that there's a 1, but if 1's a factor of every number, so we want to see if we can do better than that. 2, I see a 2 in both. But is there one bigger? Oh, there's a 3. There's still one even bigger though. So we have a 6 in both sets. It's the greatest one, the biggest number in common. So that means that's the number we're going to factor out. The other numbers that are in common we call common factors, and you could factor them out. You could factor out that way as well, but you're not going to get the best answer. So the best answer you're going to get is by factoring out the greatest common factor. So that means that we're going to write the GCF, and that's our GCF, and then we're going to divide both coefficients by the GCF. So we're going to divide 36 divided by 6, and then we're going to do -6 divided by 6. 36 divided by 6 is 6. -6 divided by 6 is -1. So we're going to get 30. We did 36t. Maybe it's better to even write that t in there so we don't forget it. T. So then we get t right here. 36t divided by 6 would be 6t. And then we have -1. So you'd have 6, and then you have 6t minus 1 in parentheses. Alright, I know this is a longer video, but I think it's a tougher topic, so I'm going to do one more. In fact, yeah, let's do this one. Okay, because this one you see has two variables. It doesn't change much. It, when you start introducing more variables, it does make a difference, but with how you do these. But we're practicing with the coefficients today. So you're going to see that these shouldn't get too complicated. Um, but we can definitely solve this. We have the information. We know the steps to solve this. So I'm gonna do this one a little differently than the others. Um, it's really the same thing. You can do this with the others. I probably should have done it before, but you can solve it the way I was showing you. You'll see it's not much extra. So we have 12y. So we have 12. We have negative 15. And I'm gonna put it. Well, we'll leave it like this actually. So we're just gonna do this like before. If you list off the factors of 12, we know 1 times 12 would work. 2 times 6, 3 times 4. So we write it like this. Doesn't have to be in order, but it is a little easier just to see it, I think. Um, Factors of 15, we're just going to ignore the negative. It's just easier like that for now. 1, 3, 5, 15. So now we're looking for the greatest factor in common with both these sets. We know there's always a 1 in common. Looks like it's 3. So our GCF is 3. Okay. That means in our final answer, we're going to have a 3 outside the parentheses. And then to figure out what goes inside, you need to divide both of the coefficients by the GCF. So we're going to do 12y divided by 3, 4y, and then we're going to do negative 15z divided by 3. Now with these questions, kind of the next step up, um, and what I hope this, I didn't see any on this IXL, but sometimes they sneak one in there and I miss it, like an extra complicated problem. You could actually have variables in common too, so it's actually possible to have a GCF with that's like 3x or 3x squared or something like that. Again, I don't think you should see that on this assignment, but that is possible. If you had something like, if we had the same question, but it was 12x um, minus 15x squared, you could actually say, well, each of these, this is an x times an x, so you could actually factor this out like this. 4 minus 5x. And you'd see if you took 3x times 4, you'd get 12x. And then if you did 3x times negative 5x, you get negative 15x, x squared. Right? We'd have x times another x to get the x squared. Again, though, this is something hopefully I don't think you'll need to worry about, but you know, something maybe to keep in the back of your minds. Anyways, let's go back to the main problem here. So we found the GCF. We said that was 3. We took the coefficient in each term. We had 12, or well, we took each term. We divided by the GCF. So we had 12y divided by 3. That gives us 4y. So we'll write that in. And then we had negative 15z divided by 3. That gives us negative 5z. Don't forget the variable. You don't want to do all the work and then get it wrong for something like that. Be extra careful. And by extra careful, I know you don't want to, but something that will save you time, if you know, so that you don't have to redo the questions, is if you can go ahead and check your work. So we have 3 times 4y minus 5z. I think it should just work typing it in, but let's check this real quick. So remember, you can check this with the distributive property. 3 times 4y, and then 3 times negative 5z. 3 times 4y would give us 12y. Right, 3 times 4y, 12y. And then you do 3 times negative 5z. Well, that would be negative 15c. We see that's the same thing as we started with. Right, we did 3 times 4y. And then we did 3 times negative 5z. So you see, when we factor, we're switching it around. We're undistributing it, if that makes sense. So hopefully, I know it's a longer video, but I do think it's a little bit of a tougher assignment. So we'll see how it goes. If you guys are having a hard time, just let me know. Yeah, we'll go from there. So keep up the good work, everybody. Thank you. Have a good day.